This video will cover Chapter 23, which is titled Swaps. The focus of this video will be on floating rate note valuation. Floaters, in other words. You have probably not valued floaters before, but in some cases they're quite simple to value. There's no calculations. They're just equal to $1 on their reset dates, which I'll explain to you in a minute. But when they're between reset dates, the valuation's a little harder, and there's a few steps, more than a few steps in order to value these things. So that's the focus of this video. Now, when you value a fixed rate note, you realize that, for example, you have a timeline. Start off at time 0, 1, 2, 3, and so on, and you have a what's called a fixed rate bond. The coupons are fixed. I'll just call them C. It's a fixed coupon all the way to maturity, and you call it, let's say, date M. You have maturity where you get the last coupon plus the face value, which is usually $1,000 for a bond, a typical bond. And so you get these fixed coupons, and not only is the dollar amount fixed here, but the periods in which they pay are fixed, which is why these things are called fixed income securities. Now with stocks pay dividends, and so you have D's here, and they never mature. But stocks are not fixed income because the timing of dividends can be, technically at any point in time, they can be deleted. You don't have to have a dividend every time period. There could be special dividends. And then the dividend can grow, and it often varies over time. So we are in Chapter 3 in the fixed income world, and even floating rate notes fall under fixed income analysis. Okay, so let's calculate and value a floating rate note. The first thing we want to do is we want to value a floating rate note on a reset date. And I want to prove to you that when you value a floating rate a floater on a reset date, that its value is equal to 1. So the first thing we want to do is we want to get time. We'll start off at time equals 0, time equals 1, so we'll have these time periods, and we'll do 4 time periods. And it's very helpful to figure out how many the number of days between these two periods. So this will be 182 days. In other words, we're really working off a semi-annual payment periods here, semi-annual, and where we have actual number of days. And so here we have 182 days in a 6-month period, and then 183, and so on. 184. Okay, so now what we have is the cumulative days. We start off at time 0, then we go up 182, 365, 547, and finally 731 days. So we're looking at a floater that lasts 731 days, and it has 1, 2, 3, 4 semi-annual periods. So it's basically a 2-year floater. Now, from this, what we need to do is we need to be given, and we're going to be given spot rates. Spots. Okay, the interest rate that you can literally spot with your eye is the way I like to say it. So it's an interest rate you can actually observe, and you can observe as of now. So if you have a timeline, these spot rates are observed right here where we are now. And so the spot rate could be over the first year, and it would cover this, or the first 6 months. The next spot rate would cover the next the whole year. The next spot rate would cover 3 periods, and so on. So the spot rates, which is basically a yield curve, and the yield curve looks like this. Nice round numbers to start out with. So there is our yield curve. And our yield curve, if you had to graph it, this is the way it would look in the Wall Street Journal. You would have yield here, which is the spot rates. And then you would have maturity here. And you would have period 1, period 2, period 3, period 4, which is, this would be the first 6 months, first year, year and a half, 2 years. So then you would have 4%, and then you'd have 5%, and you'd have 6%, and you'd have 7%, and you'd have an upward sloping yield curve that looks something like that. And this is composed of spots, okay, that you can observe today, and there they are, all plotted out. So you'll see something like this printed every day in the Wall Street Journal. So this is what we're given. This is all the given right here. Now what we want to do is we want to compute zero coupon prices. So zero prices, I'll call them for short, zeros. A zero coupon bond is just that. Instead of paying coupons, coupon, and then maturing at the last date with a coupon plus the face value, in other words, getting your principal back, these coupons are zero. And so what you do is you have something that pays off for $1,000, but you're really buying it based on its present value today, discounted back at the appropriate spot rate, and then that would be the value today of the zero, the price of the zero. So the first zero we want to calculate the first zero, and the way we calculate these zeros, I'll get another piece of paper to do the calculations. So here we have zero calculations. So what we're going to do is we're going to assume, I'll come back to this piece, let's get a timeline here. Right? We're going to get $1 here, and we're going to discount that back, and that would be the price of a zero that lasts 1 6-month period. And then we're going to have $1 here, so we receive $1. What's it worth today? And if we receive $1 in period 3, what's it worth today? And if we receive $1 in period 4, what's it worth today? That's what we're doing. So at t equals 1, we can figure out what that zero is worth. Take $1 and discount it back by 1 plus the interest rate, that spot rate, the very first one, adjusted for the number of days. And we're looking at the actual number of days divided by 360. That is a convention. This is LIBOR convention. And we're discounting it according to LIBOR convention, and this will equal 0.98018. In other words, if you invest 98 cents today and let it compound at 4% for 6 months, it'll be worth $1. So this is the present value. This is basically a future value. 4% is the discount rate. Then if we did that for t equals 2, we'd get the $1 that we're going to get in period 2. We're going to discount it back at the spot rate for the 2 periods. So this is the spot rate appropriate for a 2-period spot, and we're going to multiply that by 365 over 360. So we're basically saying, look, we're getting $1 here, and we're discounting it back at 5% for a whole year. Okay, and that's 365 divided by 360, is basically a year. And again, get used to the convention. This is LIBOR convention, which uses 360 as a year by convention. This will come out to be 0.95175, and then t equals 3. Follow the same. So this is 547 if you can't read it. That's 6% times 547 days divided by 360. The 547 is in the table that I was building. This equals 0.91645. So if you were to invest a little over 91 cents today. At 6% for 547 days, it would mature for at $1. Do the same thing for period 4, and you would get 0.87555. Okay. Your textbook calls these are the price of bonds. So it says this is B, T, and then TK. So T is the time period right now, typically 0, and T subscript K is the maturity, the time that it covers, or the last time period that it covers. So now I can insert these numbers into the table that I'm building. Okay. This is 0.98018. Okay, so now we have our zero discount bond prices. Keep in mind that the price of a zero, if you discount something, $1 back at 0 days, you get $1. So the present value of $1 is $1, and so the price of a zero today that matures today is worth $1. Okay, now the next thing we want to do is we want to compute forward interest rates. Okay, forward rates. Visualization of the forward rates are really important to see how these work, so you don't do the math blindly. So we have here the following 4 periods. Oops. And here's the days. And we're sitting right here, time 0, and we have the spot rates. So this is a 4% spot rate coming out here. Then the 2-year spot rate, which is 5%, and the 3-period spot rate is 6%, and the 4-period is 7%. Now the forward rates visually here are, is the interest rate right here. It's the interest rate here, it's the interest rate here, and it's the interest rate here. Now what do I mean by that? Well, first of all, the very simple thought is that, and I'll explain this and you'll see it in the math in a minute, that the spot rate and the forward rate are the exact same thing. So it's 4% here. The spot and the forward rate in the first period are always the same number. Okay. Now, the second forward rate here is this. We're asking ourselves, what is the interest rate that starts 1 period from now? In other words, 6 months from now. What is it? And it covers this 6-month period. So the one way to think about it mathematically is, look, we can invest for a whole year, 2 periods, 2 6-month periods for an entire year at 5% per year, or we can invest for 4% annually for a 6-month period, and then roll it over and reinvest at some interest rate at this point. That interest rate 1 year or 6 months from now is unobservable. It's a forward rate, and we need to compute that. Now before we actually compute it, and I'll do that in a minute, you can eye it out roughly of what that number will be, because think about it. If you get 5% on an annual basis, it's got to be, this 5% has to be an average of 4% plus another number to get the average of 5. So you're looking at something to be somewhere in the neighborhood of this forward rate to be about 6%. Now it'll be slightly different because there's 182 days in this time period and 183 days, so it'll be probably a slightly smaller number because it's over 1 extra day. So if we take this 4 and 6 and average it, we get the 5. And that's basically how it's going to work. Okay, and then now here, the next forward rate, this forward rate that we want to calculate is, okay, what is the interest rate 2 periods from now? Basically 1 year from now, what is the interest rate going to be that covers a deposit or an interest sensitive bond type thing for this time period? What would be the interest rate that we would earn? it would over this period. That's the forward rate. Again, unobservable. And then this last forward rate would be, what is the interest rate that we would get 547 days from now? In other words, 3 periods, and it covers a 6-month time frame. What would be that interest rate in the future? That's what we're trying to compute. And why are we trying to compute it? Because the coupon payments of a floater is a function of these forward rates. And I'll say it again. When you want to value a floating rate note, the coupons that this note throws off, generates, the cash flow it generates, is a function of these forward rates. Okay, so let's actually calculate the forward rates. And we're going to calculate them from the zero bond prices, the zeros that we had computed. Okay, so these are bond prices, and these bond prices are generated from spot rates. And from these spot rates, like I just showed you, from these spot rates, we can compute the forward rates. And that's what I'm going to do here. So we got the very first bond price, 0, is 1, minus the bond in the next period, that bond price, divided by that bond price, and then we need to annualize it. Okay? And when we do that, we get 4%, which is exactly what I told you a few minutes ago and showed you that a minute ago that the spot and the forward rate for the first period are the same number. I just showed you that. Now let's look at the second forward rate. We're going to take the 0.98018, the bond price in the first period, minus the second period. Annualize it, and we're going to get 0.0588. Okay. And we do the same thing for the next period. And we get 0.0762. Now remember what I said here. I said that this price, this interest rate ought to be, this forward rate ought to be about 6%, because 4 and 6 averaged out give you 5, but we had to adjust for the time periods, 1 day extra. And look what it is. It's almost 6%, as we thought it would be. Now, look at this near 8% interest rate, and that 8% interest rate is this one right here. It's about, this one is 0.0762, and what does that interest rate, how do you interpret that? Well, you're indifferent between investing for 3 periods at 6% versus investing for 2 periods at 5%, rolling it over to 7%, 7.6%. And then on average, when you average these out and adjust it for the time period here, this would be 2/3 basically at 5% and 1/3 at 7%. You would average out to be 6%. And if you calculate it, you can do on your own. This number should be 0.0914. Okay, so now we have our forward rates. And fill in the table. Now what we need to do is, the next step is we want to compute the projected coupons. What is the actual cash flow that's going to be thrown off? Now remember, we're looking at semi-annual time periods, and these are annualized rates, and that's the way forward rates are nearly always disclosed, on an annualized basis. So what we need to do is adjust this for the time period. And that time adjustment is not that difficult. Okay. I'm going to take the 0.04 and adjust it for the time period that we're dealing with. And when I do that, I end up with 0.02022. That is going to be the coupon. Basically, it's saying for every dollar in par value that we have for a floating rate note, we're going to get about 2 cents, 2% on that for a semi-annual period. And that's the first coupon at period T equals 1. And then get the next coupon. And that'll be the 588 we just calculated, adjusted for the time frame. And then the next interest rate, okay, so now we have our projected coupons. Okay, and I'm going to fill in that column. .02022. Now, a couple more steps. We want to calculate the present value of the coupons. What are they worth today? Because we're getting this coupon payment 1 period from now. We're getting this guy 2 periods from now, 3 periods, and 4 periods from now. So let's compute the present value. So all I'm going to do is multiply the zero prices times the projected coupons. The zero times this, because these zeros are discount factors. Okay, those discount factors are a function of the spot prices here. So you see what happened was I had all these spots and I had the time frame, and from that I can compute zeros, forwards, projected coupons, present value of coupons, and from there it's only 1 or 2 little steps to calculating the value of the whole forward, the whole floater. Okay, so when I multiply these out, for example, I'll take 0.02022 times 0.98018. Okay, so I'm multiplying them by the spot prices, the zeros, which are from the spots. Let's see, 98. This one is 0.028427, and if I keep doing this, 0.03852. The next one would be 0.0409. So let me fill in the table. 0.01982. Now, this is the present value of the coupons, and when you have the present value of coupons, everything's lined up on one at the same time frame. Everything's lined up basically. Everything's valued right here at this time frame, time 0. So we can add them up, and we add those up, we get this number. This number is the present value of all the coupons that this floating rate note is going to throw off over its life. They're expected now because we don't know what's going to happen, but based on the yield curve that we're observing, this is the cash flow that we expect to get, and this is how much it's worth today. There's one more thing we have to add to this, and that is this guy right here. We know that we're going to, at the end of the life, at 731 days from now, we know we're going to get $1 principal back on this note. We collect coupons and we get our investment back, our principal, par value. And that's $1 we're getting right here. So what's the value of $1 today? $1 here, and we're getting it, what is it worth today, times 0. You multiply $1 by the 0.87555, and you get 87 cents. In other words, 87.5 cents invested today at 7% annual rate for 2 years, you'll end up with $1. Okay? So this whole thing turns out to be the value of this floating rate note is $1. Just like I said, we're at a reset date at time 0, and we're saying we're going to get $1. It's worth $1 at this point. Now, that was the long method. This is called the forward method of computing a floater. Now, it has the intuition. Obviously, you get the intuition of what drives the value of a floater. There is a short method out there, and let me just show you the short method. The short method, calculations are way faster, but you need to see the intuition of what I just did to see the value of this, to see this concept. Is okay, now we know that at any reset date, the value of a floater is $1. So we're sitting right here at time 0. And we know that the value of the floater right after the coupon payment here is worth $1. We know that. But we're sitting right here. Not only are we going to have something that's worth $1, and that covers all the future value of all the floater payments out here, but we also are going to get this coupon. We expect to get 2 cents per dollar, basically, or 2% for this time period right here. We expect to get that. So what is the value of this of the floater from this perspective? Well, we're going to get $1 plus we're going to get 2 cents. Okay, now that's all in year 1 numbers, period 1, 6 months from now. We need to discount the whole thing back by the appropriate discount rate right here. The appropriate discount rate for period 1 is the 0.98018. So divide it by 0.98. Oh, I'm sorry, multiply. Back up. Multiply this by 0.98018. And what do we get? We get $1. This thing is worth $1. Okay? That's the short method. Okay, so I just showed you the short method. Again, you can do the short method in only a couple of quick steps, but you really can't see the intuition of this until I show you the forward method, which is a little bit more involved. So now the next step that we'll do is we want to see how do you value a floater in between reset dates? How do you value a floater, say at this time frame or this time frame? And you're going to find out when we value a floater in between reset dates, the value of the floater is not going to equal 1. It's going to be a little bit different. And that's what the subject coming up.